Welcome back. In the last video we used Astro pixel processor to combine a small CCD and CMOS dataset of the amazing galaxy NGC 6744. Both of these datasets are available for download from the Telescope Live website. Now we'll combine all of the datasets, produce an RGB image and then switch to PixInsight for further processing. I'll start off by loading both datasets. I've got them saved in two different directories. As before, once they're loaded, the sub-exposures are visible in the file list and are colour-coded. There are 290 frames here, so quite a large data set, and they've all been pre-calibrated by Telescope Live. It's always worth checking the quality of the frames using APP's Analyze Stars tool. Click on the Analyze Stars tab and then Analyze Stars again. With a data set this large it will take a while, so I'll jump forwards. Now this view looks quite confusing, but it's all fine. There's some very useful information here. Let's start by analysing the yellow star and star density information along the top. The vast majority of the data points are constant, but there are some frames where this has reduced, probably due to passing clouds or possible haze. We can click on the star and star density label in the file list to sort the affected frames in order. I'm going to remove the affected frames. We can't select them and do it in one go, so we'll have to go through and remove them one at a time. We do this by right clicking on each frame and then we choose Remove. Okay, we can continue and remove any other outliers in the same way. I'll do a few here to show the procedure. Yep, this should be fine. Now click Register. In this menu the settings are identical to those used in the last video. Click Start Registration. Once this is done, we click on the Normalise tab and in there once again on Normalise Lights. Now we can click on the Integrate tab. Once again everything is set to the same settings as in the last video. Come down to Set Save Directory and set a location for the 4 master LRGB frames to be stored. Once done, click on Integrate and choose a file name. I'll use 6744 big and then we'll click on OK. Now this is definitely going to take a while, so let's jump ahead. The 4 frames are now visible in the file list and we can double click on them to see how they look. Note also that there's no blending lines between the two datasets. APP has done a very good job of blending these two different camera datasets together. Let's create an RGB file now. As before, click on Tools and then Combine RGB. Change the setting to RGB1 and click Add Channel. Select the 3 RGB frames, click OK for all 3 to be combined. Now click on the Recalculate button. Yep, this looks absolutely great. Click on the Save button to save the RGB frame in 32-bit FITS format. OK, we're finished with APP. I'll now switch over to PixInsight. We're now working with the new PixInsight Lockhart version, and on screen are the combined luminance and RGB FITS files. The first thing to do is to crop the 2 files to the same size using the Dynamic Crop tool. Start with the luminance image and choose a crop size. Now back in the crop menu, click on the blue arrow button and drag it onto the RGB image. This will crop it, and now we apply the same crop to the luminance image by selecting it and pressing the green tick button. It's important that the RGB image has no remaining black borders. Now comes the exciting stuff. We'll use Blur Exterminator to apply deconvolution to the image. After a bit of experimentation, I used these values. The results are amazing as usual. Here's the before and after view. Now I'll use the same values on the RGB image. Here's the before and after views again. There's a small amount of moonlight gradients in the RGB image. I'll use PixInsight's gradient correction tool while we're here, but other options are APP and Graxpert, which both do a great job. With these settings, I'll drag the blue arrow button onto the RGB image. Job done. First, I'll scale the images as the auto stretch has been a bit too strong. Starting with the luminance image, I'll click on the plus sign to expand the 2 brightness sliders and then drag them to a better position. The plan is to control the core better, but we also need to keep an eye on the sky background levels. We mustn't let it get too dark or clip the levels. Drag the STF's blue slider onto the Histogram transformation tool to apply the correction, then reset the STF display to linear. Now drag the Histogram transformation's blue triangle onto the luminance image. Now we'll do the same for the RGB image. So far so good. At this point, I like to apply some noise reduction using Noise Exterminator, in this case using the new version with the AI3 capability. We'll keep it simple using these settings, and we can use the real-time preview by clicking on the blue circle. With the image displayed, we can click on the image selection button and draw a small, highly magnified view of the image. Adjusting the 2 sliders allows us to choose an optimal level of noise reduction. We'll close the preview box and now apply the settings to the RGB image. Zoom in to see the before and after views. Now onto the luminance image using the same procedure. Reduce the denoise colour slider to 0 as it's a monochrome image. Let's zoom in for before and after views again. Yeah, it's incredible. A lot of Astro imagers prefer to work with 32-bit files, but as we'll be switching to Affinity Photo in the next video, I find it much more simple and convenient to work with 16-bit TIFF files. For each image, click Save As and then choose TIFF and then 16-bit from the second menu. In the next video we'll switch to Affinity Photo for further image processing. I'll see you then.